Okay, today we're going to look at one-to-one functions. So we're going to take a look and see we have some similar mappings that we did when we looked at domain and range. And that's because we have to consider the domain and range in order to determine if we have one-to-one functions. So first, we're going to see we have an f of x function and a g of x function that we are going to map the domain. So kind of like we did in our last set, we're going to, in our f function, so if f of x is 2x, anywhere I see an x, I make it a -2. So f of -2 would get me 2 times -2. That would get me a -4. Okay, we do the same with 0. So f of 0. So 2 times 0, anything times 0 is 0. And we do the same with +2. So now I have 2 times 2, which gets us 4. And that mapping would show 2 goes to 4, 0 goes to 0, -2 goes to -4. Okay, do the same thing over here with g of x. So g of x is x squared. So we're going to plug in -2 to begin with. So I have -2 squared. So remember, you're squaring the negative and the 2. So -2 times -2 is +4. So I know -2 goes to +4. If we do the same with 0, so I'm going to have g of 0, meaning I have 0 squared, which is going to give us 0. Then we're going to do the same thing with +2, so now I have g of 2, which is 2 squared, so 2 squared times, or 2 times 2 is going to get you 4. So notice what happens with our mapping. Okay, so it says, what is fundamentally different between these two functions in terms of how the elements of the domain get mapped to the elements of the range? Well, if we're looking at our f function, we could say in the f function, we could say each member of the domain has a unique member of the range. So every member of the domain has a unique member of the range. If I'm looking at our g function, that's not the case. The g function, we could say members of the range are repeated. Two big differences there. Okay. So that brings us to this whole concept of a one-to-one function. So what really is a one-to-one function? So a function, it's going to be called one-to-one. First off, if I have two different x values, which would imply that when I plug it into the function, I get two different values. So in other words, different inputs get different outputs. So if I were to look up above, I need different inputs giving different outputs. That would mean our first function here, different inputs give different outputs. I could say that this is going to be a 1, 2, 1 function. Where back up here, I have different inputs giving the same outputs. So I would have to say that this is not 1-to-1. So with that in mind, let's take a look at some of these tables. Okay, so it says describe the different relationships below, determining if they are functions and/or we're going to see if they are one-to-one functions. Okay, so the first idea with a function is if it's a plain old function, every x value would have to have a unique y value. So if I just take a look at that, if we go through each of these, each x value has to have a unique y value. Well, that automatically fails the function. So I would say this is not a function because we know that every x value doesn't have a unique y value. So if it can't be a function, it's definitely not a one-to-one function. So not only is this first one not a function, but it's not one-to-one. Okay, so if we go back, start again with, is it a function? If it's a function, each x value is going to have a y value. So x value, y value, x value, y value, and I don't have any repeated x values. Even though I have repeated y values, each of these x values aren't repeated. Back here I had x values that repeated and gave you the same y, no repeating of the x values. So this is a function. No problem. Okay, is it a one-to-one function? Well, we'd have to say not a one-to-one function because each x value, each input, doesn't receive a unique output. And I can see that right here. I have an input that gives me an output. I have another input that gives me that same output. So this is not one-to-one. Okay, each input doesn't have a unique output. Okay, same thing here. So let's try here again. First, start off with the basic, is it a function? Okay, do I see any repeated y or x values? No repeated x values. That's good. Do I have any issues over here as far as having maybe the same y values coming out like I did in this chart? I have nothing that's repeated. So no x values repeated with different y values. So that means it is a function. Number one, so yes, it is a function. Number two, every input here has a unique output here. So that means that not only is this a function, but this is a one-to-one function. We're going to try this one again. So I have to see, first off, we try and see, is it a function? If it is a function, I shouldn't have any x values that are repeated, and automatically I see right here, I have a couple of x values that are repeated. That means for my inputs, I don't have unique outputs. So -2 produces two different outputs, and we can't have this. So this is not a function. So now we're going to take a look at it from a graphical standpoint. Sometimes thinking of it on graphs is a little bit easier. So we're going to consider the 4 graphs, and it says circle the 2 graphs above that are functions. Okay, easy way to tell if it's a function, we said, is it has to pass the vertical line test, vertical going up and down. And if I'm looking at this, I can say, yep, that definitely passes the vertical line test. So I could say number 1 is a function. I can see this one fails the vertical line test because even right here, I had 1, 2, 3, 4 different points. Okay, same thing here, 1, 2, 3, 4 different points, that fails. This guy here fails the vertical line test. As soon as I draw that vertical line, then it's hitting more than 1 point. Okay, over here, this one's good, passes your vertical line test. So I know that this has to be a function. So 1 and 4 are functions, and I can say I know that they're functions because they pass the vertical line test. And we could also say my inputs would give me 1 output. Each input gives me 1 output. Input, 1 output. Okay, of the 2 graphs we circled, which one is one-to-one? And how could we tell? So if I think back to the chart, I'm thinking I had repeated y values. So I don't want to have repeated y values. So if I take a look over here, just for instance, I can see this y value and this y value are going to be the same. You can see this y value and this y value are going to be the same. They would go the same place on that y-axis. So this is not one-to-one. But over here, I don't have a repeated y value. Nowhere do I have another point that's the same y value. Notice the type of drawing that I'm doing on this to check out that y value. Okay. So I would say number 4 is going to be our one-to-one function because none of our y values have occurred more than once. And like I said, notice the picture we were drawing horizontal lines this time. So our horizontal line test, it says if any given horizontal line passes through the graph of a function at most one time, that's your key there, then that function is 1 to 1. Notice we're already assuming that it is a function. It says a graph of a function. So it has to be a function to begin with. Then if we go and we proceed to do the horizontal line test and it only hits it once, then I can call it 1 to 1. All right, and it's saying because it's representing constant y values here. So if a horizontal line intersects a graph more than once, the output has been repeated. So checking out, these graphs, it says describe the different relationships below, determining if they are functions and or 1 to 1. Okay, so very first thing, like we did with the tables, we're going to see, are they functions? Is this a function? Not a function. Fails the vertical line test. Okay, is this a function? Well, this one looks like it's a function. Anywhere I draw my vertical line, it would pass it. So I can say, yes, it is a function. Now that it's passed that test, I want to see, is it 1 to 1, meaning draw horizontal lines. And it's not. It fails the horizontal line test. So I could say, yes, it is a function. It is not considered 1 to 1. The next one, is this a function? In fact, yes, this is. Everywhere I draw my line, it is definitely a function, so we're good. Now we can move on to the horizontal line test. And if I'm drawing my horizontal lines, again, I'm only getting one answer. No matter what, it's only hitting my graph once. So not only is it a function, but it's going to be considered a 1 to 1 function. Okay, and this last one, this is still a function, right? Passes the vertical line test. Everything is good. So I can say, yes, this is a function. Now, since it passes the vertical line, go to your horizontal line. Horizontal line is going to fail. I'm going to hit it at more than one location. So I can say not 1 to 1. And our last question. So the distance that a number x lies from the number 5 on a one-dimensional number line is given by this function. Notice it's our absolute value function. And it's saying to us it's the distance away from 5. So show by example that that is not a 1 to 1 function. Okay, so let's say, for instance, I want x to equal 5. So let's evaluate this function. I'm sorry, x to equal 8. We're going to evaluate the function at 8. So I'm going to plug in an 8, and we're going to simplify. So 8 minus 5, I get 3. And the absolute value of 3 is 3. So my function, when evaluated at 8, gives me 3. Well, I have to think to myself, okay, if I have to show by example it's not 1 to 1, I want another output of 3. So how am I going to be able to make this absolute value function also equal 3? Well, if I could produce this to be a -3, the absolute value of -3 would be 3. That would give me the same output. So how do I make this equal -3? Well, what if d was 2? Okay, so if I plug in 2 and I subtract out 5, if I simplify here, I get -3. What do we know about the absolute value of -3? We know that it's 3. So the d of 2 also gives 3. Notice I have the same outputs. Okay, so the output has been repeated. So it's not 1 to 1. As soon as you repeat an output, not a 1 to 1 function. Okay, bring any questions you have to class. We'll go over this a little bit more, and have a wonderful day.